Alrighty, let's take a look at question number 9. In question number 9, you're going to be assessed on how to find the area between two curves. So before we get started, let's take a look at the formula that will be guiding our problem solving process for this example. Alright, so as a formula for the area between two curves, formula is as follows. The area is the integral from x left to x right of f top minus f bottom with respect to x. We're using dx in this particular problem because of the orientation of our functions. We have a top-down orientation. If you look at the functions that are given, they're functions of x, right? So that automatically tells us that this is the case right here. For other cases, for your horizontal configuration, just go to mathgotserved.com on the AP Calc. We have our formula sheet there, and you can see all the formulas that you need to know to do well on the exam, including the area formulas. All right. Okay, so all we need to do here is find out what our top bottom functions are: x left, x right. Integrate, applying FTC 1, and then we'll be good to go. All right, so let's identify our functions. So we have a linear function here and a quadratic function. So if you think about it, in order for them to bound an area, considering the fact that this quadratic function is downward opening, is it obvious that the top function will have to be the quadratic? So you have a quadratic function on top and a linear function on the bottom, right? So they can bound an area. The reverse will not make any sense. Okay. All right. So let's go ahead and do it. So f top is going to be your quadratic function, which is 7x minus x squared, and then f bottom is going to be your linear function. Okay, let me just give you a visual of what we're talking about. Some of you might be able to visualize it in your head, which is excellent, but let me just give you a visual. So we have a situation like this. We have a quadratic function. It looks let me sketch it again. It's just a rough sketch just to give you a visual. So we have a quadratic function that looks something like this, and then we have a linear function that looks something like this. You know what y equals 4x is, okay? So this bounds, notice the question says the bounded region by the two graphs. So it bounds this particular region right here. So we're trying to find out what this area is, okay? So they both start from 0, and then they both intersect at a particular point right here. So let's go ahead and figure out what that point of intersection is, because we know that the left, well, we know what x left is going to be 0, right? And then we have to figure out what x right is. But let's assume that we don't know what x left is. So let's find both of them algebraically. Let's find x left and x right. All right, so this will be x left right here, and the x right will be this point of intersection. Now, how do we find x left and x right? We just simply set both equations to each other and solve algebraically. Okay, so we have 4x is equal to 7x minus x squared. Okay, so we can add x squared to both sides and subtract 7x from both sides. So you have x squared minus 3x equals 0. Factor out x, and you have x minus 3 equals 0. If you use a zero product property, x is equal to 3 or x is equal to 0. Okay, so our x left is 0, and then our x right is 3. It's not drawn to scale, so all right, so we have everything that we need now. So we're gonna just put it all into the formula. Okay, so x left is a smaller one, is 0, x right is 3, and then we have f top and f bottom here. Ladies and gentlemen, we're ready to go. So the area is going to be the integral from 0 to 3 of f top, which is the top one. F top is the green function, right? So f top is our quadratic, 7x minus x squared minus f bottom, which is 4x. All right, the bottom function is a monomial, so I don't have to put a parenthesis. But if you have a binomial, you want to put a parenthesis there because the signs will flip when you distribute. Alrighty, so let's simplify our integral first, and then we're going to use FTC1 to finish this off. So we have the integral from 0 to 3 of combined like terms. We have negative x squared, and then 7x minus 4x is plus 3x. All right, so let's go ahead and integrate. So FTC1, you integrate and evaluate it at the top minus the antiderivative evaluated at the bottom, okay? So when we evaluate it, let's find the integral. If you evaluate the integral using the power rule, it's going to be negative x to the 2 plus 1 over 2 plus 1 plus 3x to the 1 plus 1 over 1 plus 1. We know what the drill is here. Okay. Oh. Moving right along, we're going to have negative x to the third. Well, this is, we're evaluating it from where? We're evaluating it from 0 to 3, the entire thing. So let's make it look pretty. So have negative x to the third over 3 plus 3x squared over 2, evaluated from 0 to 3. So plug in the top minus you plug in the bottom. So if we plug in the top, we're going to have negative 3 to the third over 3 plus 3 times 3 squared over 2. When you plug in 0 in these two terms, the entire thing becomes 0. Okay, so you don't have to bother yourself with that. Let's go ahead and simplify this. This becomes negative 27 over 3 plus 3 times 3 is 9, 27 over 2. And then we can simplify this further. This becomes 27 over 3 is 9, so we have negative 9 plus 27 over 2. All right, so make this into fraction, times this top and bottom by 2. That gives us, what does that give us? Negative 18 over 2 plus 27 over 2. And then you combine the numerator, keep the denominator, you're going to end up with 9 over 2. Our final answer for question number 9 is option letter D. That's the answer right there. All right, so ladies and gentlemen, this is basically how you find the area between two curves by applying the fundamental theorem of calculus part 1. Thanks so much for taking the time to watch this presentation. We appreciate it. If you found the contents of this tutorial helpful in your preparation for the upcoming AP Calculus AB exam, do give us a like or a thumbs up. Do not forget to subscribe to our channel for updates to other great math tutorials such as this. If you have any questions or comments, just put it in the comment section below as indicated earlier. Tons of support resources can be found at our website, mathgotserved.com, under AP Calc, and also in the links in the description below. Thanks again for watching and have a wonderful day. Goodbye.